Hello, I'm finishing section 7.1 on linear equations. The next topic is the slope of a line. So the slope of a line measures its steepness, or how steep a line is. It measures the steepness of a line. Okay, so let's suppose we have a straight line. On the coordinate system, we have a straight line. So that straight line passes through 2 points. The points are x1, y1, and x2, y2. So these are the points on the line, are x1, y1, and x2, y2. Okay, so we have the coordinates of this point. So the change in x, that is whenever this line moves from the point x1, y1 to the point x2, y2, we need to consider the vertical and the horizontal displacement. The horizontal displacement is going to be x2 minus x1. And the vertical displacement, I'm going too far. The vertical displacement, it's from y2 to y1 is, or from y1 to y2 is y2 minus y1. So the horizontal displacement, we can also call it the run. When the line moves horizontally, we can see it as the run, and the vertical displacement, we can see it as the rise. And the slope is going to be the rise over the run. A more formal definition is on page 311. I'm about to copy that. And if x1, y1, and x2, y2 are 2 points on a line, and x1 does not equal x2, then the slope of the line is defined as the rise over the run, which is also the change in x over the changing, or the change in y over the change in x. But the change in y is y2 minus y1, and the change in x, that's the run, that's x2 minus x1. So I'm doing some examples with the slope formula, and then I'm going to do an application. In this example, we're going to calculate the slope of the line that contains the points. The first set of points is -3, 2. And 614. Okay, so this is, so the points are, let's call the first point x1, y1, and the second point x2, y2. Okay, so the slope is denoted with the letter M. It's what? This y2 minus 1 minus y1. So that's 14 minus 2 over 6 minus negative 3. 14 minus 2 is 12. 6 minus negative 3 is 9. So the slope is 12 over 9 or 4 over 3. Okay, so when it runs 3 units, it's going to rise 4 units. MB, we're going to use the formula. To find the slope of the line passing through the points 8, 5, 14, negative 9. So 8, 5, the coordinates of 8, 5 are x1, y1, and the coordinates of the second point are x2, y2. The coordinates of 14, negative 9 are x2, y2. The slope, it's y2 minus y1. So that's negative 9 minus 5 over 14 minus 8. Negative 9 minus 5 is negative 14. And 14 minus 8 is 6. Or you can simplify this fraction as negative 7 over 3. So as it runs 3 units, it falls 7 units, or as it runs 3 units back, it rises 7 units. Okay, so I'm going to do an example with the application. That's example 5 on page 312. Okay, so I'm going to copy the statement, and then I'm going to copy the graph. That's page 312. Okay, so I'm trying to copy this graph. And there it is. Okay, so the graph below shows changes in the US population from 2000 to 2018. Find the slope of the line segment representing the change in the number of 20 to 29-year-olds and the change in the number of 60 to 69-year-olds. Okay, so let's do part A. So we have points. The line above passes through the points 2000, 39.9, and 2018, 45.4. And the line below passes through the points 2000, 20.3, and 2018, 37.4. So we can see that the red line, at the first sight, we can see that the red line is steeper than the blue line. Okay, so in part A, the slope This is usually denoted with the letter M. It's 45.4 minus 39.9 over 2018 minus 2000. Okay, so this is what? This is 5.5 over 18, which is approximately 0.31. So that's 0.31 million per year. So 0.31 million per year, that's the change in population. So between 2000 and 2018, the number of 20 to 20, the number of people in their 20s increased by approximately 0.31 million per year. And then we're going to do the same for the red line. So in B, the slope is y2 minus y1. So that's 37.4 minus 20.3 over 2018 minus 2000. 37.4 minus 20.3 is 11.1. Or sorry, yeah, that's 17.1. 17.1. Over 18, this is approximately 0.95 billion per year. So on average, the number of people in their 60s increased by 0.95 million per year. And this means that they are asking you one more question. What do the data suggest? So the data suggests that the number of people in their 60s so the number of people between 60 and 69 years old increased about 3 times as fast as the number of people between 20 and 29. Okay, so a few notes about the slope. The sign of the slope tells you whether the line is increasing or decreasing, or whether it's rising or falling from left to right. So a line with positive slope rises from left to right. That is, both the rise and the run are positive, or both the rise and the run are negative. A line with negative slope falls from left to right. So the rise and the run have opposite signs. A horizontal line has slope equal to 0. And number 4, the slope of a vertical line is undefined. Okay, we have a few things. So if the line, or if the slope of the line is positive, the line rises from left to right. So this is an example of a positive slope. That is, M is positive. A line with negative slope falls from left to right. So the rise and the run have opposite signs. So either the line falls as X increases, or it rises as X runs backwards. Number 3, a horizontal line has slope equal to 0. So no matter how far you run, no matter how far the line runs, it's never going to rise or fall. So the rise is 0 regardless of the value of the run. And the slope of a vertical line is undefined. So there is no horizontal displacement, there's never a run, and you cannot even tell whether the line is rising or falling. So the third example, the horizontal line has slope equal to 0, and a vertical line has the slope of a vertical line is undefined. So if the line is non-vertical, we can always write it in slope-intercept form. Slope-intercept form of a non-vertical line. So I'll copy this definition. On page 313. A linear equation is in slope-intercept form if it is written in the form y equals mx plus b. The number m is the slope of the line, that is the graph of the equation, and 0, b is the y-intercept. So we have the line. So the y-intercept is 0, b. xy is any point. And the slope, if the line is non-vertical, the slope is m, and m is y minus b over x minus 0. Or x minus 0 is x, so mx is equal to y minus b, or mx plus b equals y, or what we have there. y equals mx plus b. So this is where the slope-intercept form is coming from. And if we have the equation of a line in slope-intercept form, we can draw the graph. So we can sketch the graph of the equation y equals minus 3x plus 5. Okay, the slope is -3. Or you can see it as -3/1. So as the line runs 1 unit, it falls 3 units. So if it runs 1 unit back, it's going to fall 3 units. And the y-intercept it's 0,5. If we compare to the equation that we have above, b is 5 and m is -3. It looks like this whiteboard. Okay, there it is. So we know the slope and the y-intercept, and we can plot a few points. Okay, so I'll stop sharing for a moment, and yeah, I'm going to close the board and reopen it. Looks like there's a problem. Okay, let's try again. So let's try sharing the screen. Okay, so we're going to sketch the graph of the equation minus 3x plus 5. The slope is -3, and the y-intercept is 5. It's 0,5. And from there, we can plot at least 3 points. Okay, the slope is 0,5. Then if it runs 1 unit, it falls 3 units. So another point is 1,2. We can do another one, run 1 unit, fall 3 units. And another point can be 2, -1. Or we can go 1 unit back and rise 3 units. So that's -1, 8. Did you get the idea? Just from the equation, from the slope and the y-intercept, we were able to plot a few points and draw the graph. So I will finish this section with a couple of applications. First application is on page 317, number 54. Okay, trying to find the problem. Actually, that's 316. Okay, Caesar is renting an LCD projector. The rental company charges a $10 flat fee for administrative costs plus 18 per day for the projector. If Caesar had a bill of $82, how many days did he keep the projector? Okay, so the rental company charges a $10 flat fee. So at the moment you sign the agreement to rent the projector, you are agreeing to pay $10 no matter what. And you're going to pay $18 for the projector. So let's see, determine the cost. See, determine the cost of keeping the projector for X days. Okay, so C is going to be $10. Caesar is going to pay $10 no matter what, and then $18 per day. So that's going to be $18 for 1 day, 36 for 2 days, 54 for 3 days. So 18 times 1 for 1 day, 18 times 2 for 2 days, 18 times 3 for 3 days, and so on. So that is going to be the equation representing the cost of keeping the projector for X days. And then, if Caesar had a bill of $82, how many days did he keep the projector? So if C is equal to 18, not 18, 82, we're going to find X. Then we're going to solve. $10 plus 18x equals 82. That's a linear equation. We can solve it by subtracting 10 from both sides. So 18x is 72. And dividing by 18, dividing both sides by 18. So X is equal to 4. This means that Caesar kept the projector for 4 days. Okay, next application is problem 62. Now this is on page 317. Okay, so I'm going to copy the description. The higher education price index graph shows the changes in college faculty and administrative salaries between 2004 and 2019, using a base year of 1983. For example, a index of 240.7 for faculty salaries in 2005 would mean that college faculty salaries in 2005 were 240.7% of what college faculty salaries were in 1990. Use the graph to do exercises 61 through 64. And I'm going to copy the graphs. So we can see the graphs. Okay, so in 2004, college faculty salaries were 200. Let's see. Yeah, 2004 were 234.2% of what they were in 1983. And in 2019, faculty salaries were 342.2% of what they were in 1983. And we can say the same about administrative salaries. Okay, so we're doing number 62. Actually, we're doing 61. Yeah, we're going to do number 61. Okay, we're going to find the slope of the blue line representing the change in the index for faculty salaries. So we're looking at the blue line, and it says treating 2004 as year zero, write the equation of the line representing the change in the faculty salaries index in slope-intercept form. The points are going to be 0, 234.2, and 2019, that's 15 years after 2004, so that's going to be 15, 342.2. The slope is done. It's 342.2 minus 234.2 over 15 minus 0. So 342.2 minus 234.2, that's going to be 100. That's going to be 108. 108 over 15, and 108 over 15. I'm going to put this on my calculator. It's 7.2. So we got that part. And then in part B, we know the slope, we know the y-intercept. The y-intercept is 0 to 134.2. And the equation of the line is going to be y equals 7.2x plus 234.2. Okay, and I'm doing one more example. Number 76 for comparing food plans. College students can purchase points that can be used in the food service areas instead of cash. If you initially pay the basic food service fee of $35, then points can be purchased by 23 cents each. Otherwise, points cost 30 cents each. How many points must you use for it to be cheaper to pay the basic food service fee? So if you're using the food services often, it is going to be more convenient to pay for the basic food service fee or to purchase the basic plan. Otherwise, if you're going every once in a while, don't purchase the plan. Okay, so we have two plans. Plan one is that you pay a basic food service fee of 35, and then points can be purchased for 23 cents each. Otherwise, points cost 30 cents each. Okay, so let y denote the cost of purchasing X points. Okay, so the equation for the basic plan is going to be y, and then you have the basic food service fee for $35 plus 23 cents per point. And the equation for no plan is y equals 0.30x. So you're not paying a fee, but you're paying more for points. Okay, so on if we were plotting the lines, we would have something like this. That the basic plan has y-intercept 35. So this would be for the basic plan. And the for no plan, the y-intercept is 0,0, but it has a larger slope, so the line is going to be steeper. And they are going to intersect at the point where these two are equal. We need to solve or find x. So that 35 plus 0.23x equals 0.30x. So once we solve that, we're going to find the value of x, for which these two, the value, the number of points, for which you're paying the same for either the basic plan or no plan. And from there, we can tell how many points must you use for it to be cheaper to pay the basic food service fee. But let's solve this equation. 0.30x equals 35 plus 0.23x. Subtract 0.23x from both sides. And 0.07x is equal to 35. And divide both sides by 0.007. And x is 500. So these two are going to be equal when x is equal to 500. And finally, you must purchase at least 500 points. Or you must use at least 500 points. Thank you for listening.